In this video, we are going to see about Python built-in functions completely. There are more than 60 built-in functions in Python. Mostly, all the built-in functions are arranged in the alphabetical order in this video, except some function which is related with other functions. The starting time of each function is mentioned in the description, which is given below. Now let us start it. Let us see about ABS built-in function. This is a syntax for ABS built-in function. This will return the absolute value of x. What is an absolute value? First, let us understand what is an absolute value. An absolute value is a measure of distance from the origin. For example, if 0 is an origin, if you want to find how far is 5 is from origin, the distance is 5. Similarly, if minus 5.5 is there, how far it is from origin? It is not minus 5.5. It is 5.5. We are finding only the distance. Similarly, if this is a complex point, for example, 5 plus 2j, we want to find how far 5 plus 2j is from origin. How we will find? We can find using Pythagoras theorem. That is, it is a and this is b. Therefore, d equal to root of a square plus b square gives this particular d. Now let us get into the coding part. So, absolute of x will give 5. Minus 5.5 will give 5.5. 5 plus 2j will give square root of 5 square plus 2 square. Let us run the code and check the output. So here the answer is 5, 5.5, 5.38. The square root of 5 square plus 2 square is 5.3851. Let us build the ABS built-in function by ourselves. In this example, we are importing math ASCII. If the input is a complex number, what we are doing here is we are finding the real part of that and we are finding the imaginary part of it and we are squaring it. That is a square plus b square. Then we are taking the square root of s1. So we are taking square root of s1 and we are returning s2. If x is not a complex number, then if it is negative, we are just returning the positive value of that. If it is positive, we are just returning x. Let us run the code and check the output. For this is the answer. For this is the answer. For this is the answer. This and this both are same. This is about ABS built-in function. Let us see about all built-in function. This is a syntax for all built-in function. So what is the use of this function is, this function will return true if all the elements are non-zero or true, or it's an empty. Else this will return false. If any one of the element contains 0 or false or none, this will return false. So this is about all built-in function. So for this input all are non-zero, so the output will be true. For this the output will be false. For this it contains one false, so the output will be false. This is an empty, so the output will be true. It contains one none, so the output will be false. Let us run the code and check the output. For this true, for this false, for this false, for this true, for this false. So this is about all built-in function. Let us create the all built-in function by ourselves. This is one of the way to create all built-in function. Let the name of the function be all1. So we are running the loop from the starting of the element to the end of the element. If any one of the element contains 0 or none, this will return false. Else this will return true. For the same input, let us run and check the output. For this true, for this false, for this false, for this true, for this false. So this is our function all1. This is about all built-in function. Let us see about any built-in function. This is a syntax for any built-in function. The input is an iterable. This function will return true if any one of the value is true or non-zero. If any one of the value is true or non-zero, it will return true. Else it will return false. See here all the inputs are 1, so the answer will be true. Here 0 false none, so no true and no non-zero element is there, so it will be false. Here one of the element is 1, so it will be true. It is an empty, so it is false. Here one of the element is 1, so it will be true. Let us run this code and check the output. True for this, false, true, false, true, true. So let us create an user defined function for any built-in function. So this is one of the way to create an user defined function for any. Okay, we are running the loop from the starting value to the last value, and we are checking if any one of the value is not 0, return true, else return false. So let us see the same input and let us check the output. True, false, true, false, true. Here also true, false, true, false, true. This is about any built-in function. Let us see about ASCII built-in function. This is a syntax. The input is an object. So what is the use of this ASCII built-in function is, this will convert the given object in the form of string so that it can be in the form of printable representation of an object. Printable representation of object, and also this will convert the non-ASCII characters into ASCII characters. For example, if we see the input, my name is so and so. This is a Tamil language and this is a Chinese language. If we find an ASCII of an object, so you will be getting a string which is a printable representation. So this is print text. So we want to know what is this Unicode of this is what. So we are finding odd of this. Then we are finding the hexadecimal of 32593 because the Unicode of this is 32593. The Unicode of this is 32476. So this is the first part of ASCII. Let us understand up to this. Later let us understand this. First let us run this code and check the output. Here we are printing X. The X is coming, my name is 7F51 U7EDC. Again this is Tamil language. This is Chinese. We are finding the Unicode of this particular symbol and this is 32593. This is 32476. So what is the hexadecimal value of 32593? Hexadecimal value of 32593 is 7F51 7EDC. We have seen somewhere here, that is here. So what it is doing is, it is converting the non-ASCII characters to ASCII value which is in the form of hexadecimal. So this is about ASCII. Now we are seeing about what is this U. This U is coming. What is this U? Sometime X is coming. Sometime capital U is coming. So what is the difference between all these things in an ASCII built-in function? If you see here, means for 130 it is coming X82. This is for 130. For 57345 this is coming UE001. Okay, this is 4, this is 2. For 111411 this is coming 00104F. So this contain 8, this contain 4, this contain 2. So what it is doing here is, if it is an 8-bit, the prefix will be X. If it is a 16-bit, the prefix will be U. If it is a 32-bit, the prefix will be capital U. So this is the use of this X, U and capital U. This is about ASCII built-in function. Let us see about GETATT, SETATT, ASCII, DELATTAR built-in function. This is a syntax for GETATT. It contains 3 parameters. One is object, name and default. Let us take an example. Here cat is a class which contains 3 attributes: legs equal to 3, tail equal to 1, eyes equal to 2. So what is the use of this GETATT is, this will get the attributes of that particular object. If that attribute is not available, then it will return the default value. For example, this is an object cat, attributes default. Now we are planning to access the legs of cat. What is the value? The answer is 3. So it will return 3. So the answer here it will become get at equal to 3. Now we are planning to access wings attributes of cat. Wings is there or not? No. So it will return not available. So here the answer will become get at equal to not available. This is about get at. Now let us see about set at built-in function. This is a syntax for set at built-in function. It contains 3 parameters. One is object, name and value. So what is the use of the set at built-in function is, with the help of this set at, we can change the value of the attributes of the given object. For example, if I want to change this into 4, then I can write cat legs 4. After doing this, now the value of the legs will become 4. If you want to check whether the value has changed or not, we can use get the attributes and we can check it. The value is changed, here it will print set attribute equal to 4. This is about set at built-in function. Now let us see about as at built-in function. This is a syntax for as at built-in function. It contains 2 parameters, one is object and another is name. So what is the use of this at built-in function is, if that particular attribute is present in the object, it will return true, else this will return false. This will check whether that attribute is present in that object or not. If it is present, it will return true, else it will return false. For example, we are checking whether the eyes attribute is present in the cat, whether eye is present, yes. So this will return true. If this is returning true, we are changing the eyes to 1. Initially this is 2, we are changing to 1 and we are getting the value of the eyes and we are printing here. So this as attribute I equal to, it will print 1. So as attribute will check whether it is true or not. This is about as at. Now let us see about del at built-in function. This is a syntax for del at. It contains object and name as an parameters. This del at built-in function is used to delete the attributes of the given object. For example, if I want to delete legs from class cat means, then I can use del at cat leg. Now this will delete the leg attribute from class cat. Now if we are trying to access leg from cat, whether it will be there? No. So it will return not available because this has deleted the legs attribute. Let us run this code and check the output. For this is coming not available. For this is coming 1 because it has changed. For this is coming 4. For this is 3. This is not available. 3 and not available. This is about get at, set at, as at, del at built-in function. Let us see about bin built-in function. This is a syntax for bin built-in function. Here the input x is a decimal number. This bin function will convert the given decimal number to a binary value. This is the use of this bin function. Let us see these examples. If we see here means bin of 5. What is binary value of 5? The binary value of 5 is 101. For 7 it is 111. For 2 it is 10. For 16 it is 140. Let us run this code and examine the code. If we see the output, for 5 it is coming 0B101. For 7 it is coming 0B111. For 2 0B. If you see 0B before the binary values, why this 0B must be added before this binary values? Because this 0B indicates the given number is a binary value. Because there is an octal value as well as an hexadecimal value. To differentiate, this is a binary value, not an octal and hexadecimal value. We are using 0B. If you think, sir, I don't need 0B prefix, just I need the binary value elements, then this is one of the way to obtain it. You can use format 5, B. If you are going to type like this, the output will be 101. So based on the format method, if you need a prefix means, you can use this method, format 5 #b. This is about bin built-in function. Let us see how to create the bin function by ourselves. This is one of the way to create the bin function. Okay. So this is a while loop. What we are doing here is, if the input x is greater or equal to 2, we are finding the remainder. We are finding the remainder and we are appending the remainder to the list B. And again what we are doing here is we are changing the x with the quotient. X double slash 2 will give the quotient, okay, and we are replacing the x by the quotient. Again the loop will run until the x will become less than 2, that is 1. If the x become 1, we are appending the final value and we are returning the values. For example, let us take the example for 16. If we see here, means 16 is divided by 2 and we are obtaining the quotient as 8 and remainder as 0. So what we are doing here is we are repeating the process until it becomes 1. So what we are doing is we are storing the value of the remainder in B. So how the value will be stored is 0 0 0 0 1, but the answer is 1 0 0 0 0. So that's the reason we are reversing the final output. So this is about bin user defined function. Let us run the code and examine the output. If we see the output, for 5 it is 101, 7 111, for 2 10, for 16 it is 140. So we made the output in the form of list. Here the output is in the form of string. So based on our requirement, we can produce the output in the string or list, whatever the manner, so that we can access it and use this very efficiently. This is about bin built-in function. Let us see about bool built-in function. This is a syntax for bool built-in function. Based on the input, this function will return either true or false, that is the boolean values. If the input is true or non-zero value, that is if it is not 0, the output will be true, else it will return false. This is about boolean built-in function. For the input, this is an empty set. The input is true, here it is 0, here it is none. Let us run this code and check the output. If the input is 2, it is true. For rest of the things, empty, 0, none, it is false. So it is about boolean built-in function. Let us create the bool built-in function by ourselves. This is one of the way to do it. If the input is 0 or none, or if it is an empty, len of x is 0, then return false, else return true. For the same input, let us run the code and check the output. False, true, false, 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 true, false, false. Both outputs are same. This is about bool built-in function. Let us see about bytes and byte array built-in function. This is a syntax for bytes. The parameters are source, encoding and error. This function will return a new byte object. This is about bytes. There are three cases. One, if the input is an integer. Next case, the input is an iterable. Third, the input is a string. If the input is an integer, it will create that particular number of bytes, new bytes. For example, the input is 10, it will create 10 new bytes. The input is a iterable. For example, here it is from 12 to 70. This will convert the iterable list to bytes. If the input is a string, okay, this will convert the given string to bytes. So here the shell is encoded using UTF-8. If any error occurs, it will raise value error. Stick means it will raise value error. Now let us see about byte array. This is a syntax for byte array. The parameters are source, encoding and error. See, all the process is same except the byte array is an mutable one. That means we can change the values. Bytes are immutable one. That means we cannot change the values. For example, if we are assigning x equal to bytes of range of 12 to 18, after assigning x, x cannot be changed. If we are assigning x equal to byte array of range of 12 to 18, the x value can be changed. So this is about byte array and bytes. Let us run the program and check the output. This is for bytes and this is for byte array. This is about bytes and byte array built-in function. Let us see about callable built-in function. This is a syntax for callable built-in function. The input is an object. This function will return true if the given object can be called. Else it will return false. For example, let us take this function x. Okay, this is returning 5. Whether this function can be called or not, yes, this function can be called. So the output will be true for this. This is a variable t equal to 5. Whether we can call this variable or not. No, we cannot call this variable. So it will return false. This is a class student. If this class contain a method called call like this, then this class can be callable. For example, S is an object, student 5, 2, print callable of S. For this, the output will be true. Let us run this code and check the output. If you see the output, for first one it is true, for second one it is false, for third one it is true. This is about callable built-in function. Let us see about CHR and ORD built-in function. This is a syntax for CHR and this is a syntax for ORD. The CHR will convert the Unicode to symbol. For example, this is a Unicode. 97, 65, 165. These are Unicode. CHR will convert this Unicode to symbol. ORD is in reverse direction. It will convert the symbol to Unicode. For example, let us run this program. If you see here means the symbol for 97 is A, small a. The symbol for 65 is capital A, and for 165 is this one. If you are going to print the Unicode for these symbols, we can get C, 97, 65 and 165. So CHR is used to convert the Unicode to symbol. This is Unicode. It will convert to symbol like this. ORD will convert the symbols to Unicode. So what is a Unicode? So this is an example of Unicode. So Unicode means it's a universal character set. Universal means whatever characters are used all over the world, most of the characters will be in this set. That is called universal character set. See, if you see means all these symbols, see starting from 0, 0. If you see means this kind of, see this symbol we have seen. So if we go through all this kind of symbol, this symbols characters will contain the languages all over the world. Most of the languages in the world, it will contain all the characters. This is about Unicode. So ASCII will contain character from 0 to 127, but this will contain all the symbols, all the characters all over the world. So this is about Unicode. This is about CHR and ORD built-in function. Let us see about class method built-in function. Class method is a decorator in Python. It takes class as an argument and returns the class. In Python, constructor overloading cannot be done. With the help of class method, we can indirectly overload the constructor. This is one of the main advantage of class method. Let us see with an example. Here, employee is a class which contains int with the parameters id, name and age. And here the data is a class method with the parameters class, name and age. This CLS indicates this employee class. So what this data method is doing here is, this is accessing class.id, that means employee.id. This is accessing this id and is incrementing by 1. After incrementing, it is assigning to IDP. After assigning to IDP, this is returning class, IDP, name and age. This class indicates employee, so this is returning employee with the parameters IDP, name and age. Now let us create an object using a constructor employee 1, Chella and 12. The parameters are ID, name and age. So the ID equal to 1, name equal to Chella, age equal to 12. So the e.id is 1, e.name is Chella. So e is an object which is created using the constructor. Now let us create an E1 object using the class method. Employee.data. What is employee.data? This data. It contains two parameters. One is name and age. Here Durai and 13 we are giving. But what it is returning? It is returning employee with IDP, name and age. So it is returning indirectly what it is returning? It is returning employee with class ID equal to 2 name equal to Durai and age equal to 13. So indirectly we are doing constructor overloading, because here the number of argument is 2, here the number of argument is 3, but with the help of this we are constructing an object E1. So indirectly we are doing a constructor overloading. So E1.id is 2, E1.name is Durai. Similarly, E2.id is 3, E2.name is Ramesh, because the id is incrementing every time. Similarly, E3.id is 4, E3.name is Kishore. Let us run this code and check the output. For this object, the id and the name is 1 and Challa. For this object, using the class method, the id and the name is 2 and Durai. For this object, it is 3 and Ramesh. For this object, it is 4 and Kishore. So this is about class method. Let us see about compile built-in function. This is a syntax for compile built-in function. The important parameters are source, file name and mode. So what is the use of compile built-in function is, this function will convert the high level language to low level details of C Python implementation. Generally we know, for the code to be executed, the code will be converted from the high level language to low level language, then the code will be executed. Here what the compile does is, this will convert the high level language to the low level details, and this will make the code to be ready for the execution. Then using the X inbuilt function, we can execute the code. This is about compile built-in function. Let us run the code and check the output. So the output is x plus y equal to 70. So the compile built-in function won't execute the code, but this compile built-in function will convert the high level language to low level details of C Python implementation. This compile will make the code to be ready for the execution. This is about compile built-in function. Let us see about complex built-in function. These are the syntax for complex built-in function. If the input is a string, then it must contain only one argument. If input is not a string, it must contain two arguments. One indicates about real and another indicates about the imaginary part of the complex number. For this, the output will be 5 plus 6j. For this, the output will be 5 plus 0j. For this, the output will be 5 plus 6j. So this is about complex built-in function. If I want to access the attributes of the complex, that is the real and imaginary part of the complex, then I can use x dot real and x dot imaginary. Let us run this program and check the output. For this, this is the output. For this, this is the output. For this, this is the output. X dot real is 5, x dot imaginary is 6. Based on this, this is about complex built-in function. Let us learn about decorator. Decorator is a very important concept in Python. Let us consider this box containing valuable items. If we want to give this box to another person for a marriage, we'll be decorating the box, right? While decorating, whether we'll be changing the internal item of the box? No. The box and everything in it will be unchanged, right? The box and everything in it will be unchanged. But we won't be changing the outer part of the box. We'll be decorating only the outer part of the box. Similarly, a decorator is a function in Python which takes a function as an argument and adds some functionality and returns it. This is about decorator. Let us learn it with an example. Here, fun is a function which prints may God bless you. This is a function which prints may God bless you. Similarly, decorator underscore fun is a function which takes this function as an argument. It is decorating something and it is printing it. If you see here, means we are assigning fun equal to decorator underscore fun or fun. That means we are calling this decorator underscore fun and passing fun as an argument. Here fun is a function. We are passing this function as an argument to the decorator function. When this is passed, now what the answer will be is, it will print 30 star and it will call this function. So it will print may God bless you. Again it will print 30 star. We can run this code and check the output. So this is a decorator. See here, this belongs to this fun. This decorator underscore fun, this is decorating and printing it. This is about decorate. Let us see about decorator using at symbol. Okay, at decorator underscore fun. So what is a decorator underscore fun? This is a function which is taking this function as an argument. This is decorating and returning it. This fun is going to print may God bless you in the center of the 30th space. If you are going to write at decorator underscore fun above this fun, what this is going to do is this is going to change fun equal to decorator underscore fun of fun. This is similar to this particular part of the code. So if you are going to run this code, we can see this output is similar to this output. So if you are going to write at decorator underscore fun above this function, so this fun will be converted as decorator underscore fun of fun. So this is about decorate. Let us see about DICT built-in function. This is a syntax for DICT built-in function. The input is a keyword arguments. Generally, we'll create a dictionary in this manner. Here A, B and C are the keys of the dictionary. 1, 2 and 3 are the values of the dictionary. Let us create a dictionary using the DICT built-in function. These are the different ways to create a dictionary using the DICT built-in function. Here the input is a list which contains tuples A and B. A is a key, one is the value associated with A, similarly B and similarly C. Either we can give the input like this, or we can give the input like this in the form of keys and values, or we can give the input in this manner. What the zip inbuilt function does is this will convert this line to this line of code. Let us run the program and check the output. If you see here means D, E, F, G all are producing the same value. So this is how we'll create a dictionary using a DICT built-in function. Let us see about dir, VARS and L built-in function. This is a syntax for dir built-in function. Here the input is an object. This function will return the list of attributes of that particular object, list of valid attributes of that particular object, and also the properties and method of that particular object. This is about dir built-in function. VARS built-in function, what it will do is it will return the DICT attributes for that particular module, class or instance. So this will return the DICT attributes. This is a syntax for L built-in function. This will return the Python documentation of that particular object. Let us see the example one by one. In this example, here the class is Chella. It contains attributes T and Raju. These are two methods, int and add. First let us run for dir of Chella. So if we see the output for dir of Chella, these are inbuilt attributes. What we are getting is Raju, T and add. Add one is a method. Raju and T are the attributes. This is about dir built-in function. Now let us see about VARS built-in function. Let us comment this line and uncomment this line. Let us run the code. If you see here means the VARS built-in function is returning the DICT of that particular module or class. See here T is in the form of key, 10 is value, Raju is in the form of key, 20 is value. So this is written in the form of DICT of that particular module or class or instance. This is about VARS of Chella. Now let us see about help of Chella. Let us run this code. See, we can see the help of Chella gives the Python documentation of that Chella class. Here Chella is a class which contains two parameters. It contains method int method and add method. It contains two attributes Raju whose values is 20, T whose value is 10. This is about help built-in function. Let us see about DIVMOD built-in function. This is a syntax for DIVMOD built-in function. It contains two parameters. The first parameter is a dividend. The second parameter is a divisor. The DIVMOD built-in function will return quotient and remainder. For example, let us take the input 5 and 2. The remainder is 1 and the quotient is 2. So the Q is 2, the remainder is R is 1. Let us run this program and check the output. Q is 2, R is 1. This is about DIVMOD built-in function. Let us create DIVMOD by ourselves. This is one of the way to do it. Here these contain two parameters. The first parameter is a dividend, second parameter is a divisor, and this is a quotient and this is a remainder. We are returning the quotient and the remainder. So if we run this program, we can see we are getting the same output. This is about DIVMOD built-in function. Let us see about enumerate built-in function. This is a syntax for enumerate built-in function. So what is the use of this function is? It's useful to obtain an indexed list. This is useful to obtain an indexed list. For example, if x is 2, 3, 4, 5, enumerate of x will give 0, 2, it is indexed with 0, 1, 2 and 3. If you are saying the index must start from 10, now the index will be 10, 11, 12, 13. After indexing, we will be obtaining an indexed list. Let us run this code and check the output. For this, it is 0 to 3 is indexed with 1, 4 is indexed with 2, 5 is indexed with 3. Similarly, for this, it is starting from 10, 2 is indexed with 10, 3 indexed with 11, 4 is indexed with 12, 5 is indexed with 13. This is about enumerate built-in function. Let us create the enumerate built-in function by ourselves. In this example, the name of the function is enumerate1. The two parameters are x and index. By default, the index is 0. If only one argument is there, the index will be assumed to 0. If two argument is there, the index will be 10. Now let us understand this code. So what we are doing here is we are creating an empty list and we are appending a with index comma x of 5. For example, we are starting from 2, 3, 4, 5 means. So x of 0 is 2. Initially the index is 0. So 0, 2 will be in appended in a. Now the index is incremented to 1. The next will be 1, 3. Now the index is incremented with 1. So 1 plus 1 is 2. So 2, 4. Now again the index will be 2 plus 1 is 3. So 3, 5. So this will return 0, 2, 1, 3, 2, 4 and 3, 5. Similarly for 10 also it will do the same process. Let us run this code and check the output. For this is the output. For this is the output, which is similar to our output. This is about enumerate built-in function. Let us see about eval built-in function. This is a syntax for eval built-in function. It contains three parameters. One is source, global and local. Source is mandatory. So what is the use of this function is? This function is used to evaluate the given source. The given source is a string, then this must be a legal Python expression or it must be an output of a compile. If that's the case, then it will evaluate the source and produce the output. For example, here x is 5. This is a legal Python expression. We are squaring x and we are adding 5. So 5 square means 25 plus 5 is 30. If you run this code, the output will be 30. So this is about eval built-in function. Let us see about X built-in function. This is the syntax for X built-in function. It contains three parameters. One is an object, and another is globals, and another is locals. object is mandatory. So what we are trying to do here is we are trying to execute the given object. Here the object is x and we are trying to execute the given object using x built-in function. Let us run this code and check the output. Here the output is 17, 18 and 19. How we are getting 17 and 18 and 19 is based on this object. If we see inside the string, here x is assigned to 7, y equal to 10, and we are running the loop from I equal to 0 to 3. That is, I will become 0, 1 and 2. So initially I equal to 0. So x is 7, y equal to 10. So 17 plus 0, 17. 17 plus 1, 18. 17 plus 2, 19. So x built-in function is used to execute the given object. This is about x built-in function. Let us see about filter built-in function. This is a syntax for filter built-in function. It contains two parameters. One is the function and another is an iterable. As the name suggests, we are going to filter the elements from the iterable for which the function will return true. For example, this is the function fn. Okay. For this function, this will return true if the input is even, else this will return false. So this is the function. We have defined a function. Now this is an iterable 1, 2, 3, 4. And this is a function. We have created a function. So when the input is 1, this will return false. When the input is true, this will return true. When the input is 3, this will return false. When the input is 4, this will return true. What this filter does is, this will construct an iterator for those element of iterable for which the function returns true. So if you run this code, we can see the output. The output is 2 and 4. This is about filter built-in function. Let us create this same kind of filter built-in function by ourselves. This is one of the way to do it. Here we have created a function similar to this function. We have created a function. This function will return true if the input is even, else this will return false. Now we have created an user-defined function called filter1. It takes two parameters. One is function and another is iterable. So what we are doing here is we are running the iterable from first value to the last value. That is, we are running the iterable from first value is from 0 to L minus 1, and we are giving that as an input to this function. If this function returns true, we are appending to A, else we are not appending to A and we are returning A. So let us run this program and check the output. If we see the output, this and this output is same. So this is about filter inbuilt function. Let us see about float built-in function. This function is used to convert the given value to a float value. For example, here the input is an integer, that is 45. This will convert into the float value, which is 45.0. Here this is a string. This will convert to a float value, that is 2.23. Minus 2 means minus 2.0. So this will convert the given value to a float value. Let us run this code and check the output. So 45.0, 2.23 minus 2.0. If you are going to try to convert a character to a float, which is not possible, so an error will occur, that is called value error. Let us uncomment and run the code. This is called value error. So we can't convert a character to a float. This is about float built-in function. Let us see about format built-in function. This is a syntax for format built-in function. We have seen in bin built-in function, oct built-in function, as well as an x built-in function, that this is one of the way to produce an binary from the given decimal number, octal from the given decimal number, hexadecimal from the given decimal number. These values will produce the octal, binary and hexadecimal from the given decimal number. Similarly, we can produce using this flower bracket also. Here input is a decimal. This will convert into binary based on B, into octal based on O, into hexadecimal based on X. Let us run this code and check the output. If you see here means 12 is converted in binary, in octal, in hexadecimal. Similarly here binary, octal and hexadecimal. This is about format built-in function. Next we'll be looking on accessing argument by position. These are the arguments of the format. Here this is 0th position argument, first position argument and second position arguments. Inside the flower bracket, if you are not mentioned anything, this will be considered as 0, first and second. So the answer will be 27-10-2021. For this we are mentioning the position. So the answer will be second position 2021. First position is 10-10-0, that is 27. For this it is 1. What is first position argument? 10. What is second position argument? 2021. So 10-21. Now if the input argument is a list, this is a list. If the input argument is a list, we can't access this list directly, so we'll be using a star. What is the use of the star is, the star will unpack this list, and with the help of this unpacking we can access each item from the argument. Now the answer will be 27-10-2021. Let us run this program and check the output. For this is the answer. For this is the answer. This is based on the position. For this is the answer. Now we are unpacking it. When we are going to unpack it, this is the answer. This is about accessing the arguments by position. Now let us see about accessing arguments by names. What does it mean? Here the argument contain name and value associated with it, year, month and date. Now we are going to access these value based on the names, date, month and year. So the answer will be 27-10-2021. Now if a dictionary is passed as an argument, then we want to unpack this dictionary. We can unpack the dictionary with the help of double star. With the help of double star we can unpack it. After unpacking, based on the name, we can access these values and we can print it. Next we are going to see about by attributes. See here the complex contain 5 plus 6j, real is 5, imaginary is 6. These are the attributes of complex number. If the argument is a complex number, then we can access the real part by 0.real, imaginary part by 0.imag. This is about accessing the arguments by attributes. Let us run this program and check the output. The answer is 27-10-2021. We are unpacking the dictionary. The answer is 27-10-2021. The real value is 5. The imaginary value is 6. Let us see how to access an arguments item. See, this is an argument. Name is an argument. The item of the name are Chella and Durai. Now how to access this Chella and Durai is 0 of 0 gives, name of 0 gives Chella, 0 means name, name of 1 gives Durai. With the help of this we can access the items of the given argument. Now let us see about R and S. R for REPR, S for string. If you are going to use R, then within the quotes the output will be printed. If you are going to use string, without the quotes the output will be printed. Let us run the code and check the output. For this is coming Chella. For this is coming Durai. For this is printing within quotes test1. For this is printing test2 without quotes. This is about accessing arguments item and how to use REPR and string. Let us see about aligning the text and specifying the width. Here colon lesser sign 30 means the space of 30th width, Chella will be aligned on the left hand side of that space. Colon greater sign 30 means in the space of width 30, Chella will be aligned on the right hand side of that space. For this, cella will be aligned at the center of the space. Let us run this code and check the output. For this, see, this is the thing. The width is 30. Cella is aligned on the left hand side. For this, cella is aligned on the right hand side. For this, cella is aligned on the center. This is about aligning the text and specifying a width. Now, instead of this empty space, if you want to use any symbol, then you can use like this: star lesser sign 30, star greater sign 30, star cap 30. We are going to run this program. We can see the output. So the output is cella star star star. The right hand space is occupied by star 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 cella. Cella is occupied in center. Rest is occupied by star. Let us see how to specify a sign using format. The arguments are 3.14 minus 3.14. If I am writing plus f, then plus 3.14 minus 3.14 will be printed. Both the signs will be printed. If I am writing minus f, that means only the minus sign will be printed. No sign will be printed in this front. Simply for writing f means space will be printed before this and minus sign will be printed before this. This is about specifying sign. Now if you want to truncate the float, for example 1.23, 4, 5, 6, 7, 8, 9, you want to get the output up to 1.23, then you can use 0.2f. If you want to find the percentage and you want to print only 2 points of the decimal pointer, then you can write 0.2 percentage. Let us run this code and check the output. For this, this is the output. Similarly for this, this is the output. For this, this is the output. For this, this is the output. This is about specifying sign using format method. Let us see about globals built-in function. This is a syntax for globals. This will return the global symbol table. This symbol table will contain the information related to the global scope of the program. First, let us understand what is a symbol table. A symbol table is a data structure which contains necessary information related to the variable names, methods, and classes. In this example, A is a global variable, T is a local variable. If I want to access global variable and if I want to modify it, then I can use globals of A. Here what I am doing here is I am modifying 10 plus globals of A, that is 5 plus 10, that is 15. Now A is 15. If the input to the function is 10, that is x is 10, then T will become 15 plus 10, that is 25. So let us run this code and check the output. 25. So this is the use of globals built-in function. Let us see about X built-in function. This is a syntax for X built-in function. So what is the use of this function is, this function is used to convert the given decimal number to hexadecimal value. For example, if the input is 12, what is the hexadecimal value of 12 is C. So this will convert the 12 to C. The answer will be 0xC. The 0x indicates C is an hexadecimal value. And another way to obtain an hexadecimal value is using this format method. Format 12, x. X indicates please convert this into hexadecimal value. We are informing to the format method. Now let us run this code and check the output. For 12, it is 0xC. C is an hexadecimal value. Using this format method, we are converting 12 to hexadecimal value. So the answer is C. Now let us see how to create the X built-in function by ourselves. Before entering into the coding part, first let us understand the concept. Example, if you want to convert 890 decimal number to an hexadecimal value, what we'll be doing here is, we'll be dividing 890 by 16 and we'll be finding the remainder and we'll be finding the quotient. If the quotient is greater than 16, what we'll be doing here is, again we'll be dividing 55 by 16. Again we'll be finding the remainder, we'll be finding the quotient. The quotient is less than 16, we'll be stop computing this calculation and we'll be finding the remainder alone. This remainder will give us the hexadecimal value. The another point to be noted here is if the remainder is between 10 and 15, we want to change into alphabets. Here 10 is remainder, so the alphabet is A. Let us get into the coding part of the X built-in function which is going to be created by ourselves. Let us see how to create an X built-in function by ourselves. Let the name of the function be X1. So we know in hexadecimal value 0 to 9 is saved as 0 to 9. From 10 to 15 it is saved as A, B, C, D, E, F. So what we are doing is the remainder is from 0 to 9. We are storing the same value as 0 to 9. The remainder is from 10 to 15. We are changing into alphabets and we are storing the remainder. This is the first part of the code. The second part is the main part. If x is greater or equal to 16, we are finding the remainder and we are storing in B. Next, we are finding the quotient and we are replacing the x with a quotient. We are running this loop until the x becomes less than 16. If x is less than 16, we are storing in B and we are retaining the final hexadecimal value B. X1 is the function which we have created. X is the built-in function. Let us run the code and check the output. For x144 it is coming 0x90. For x1144 we are coming 90. For this 6f111, 6f for this 111. Here the built-in function gives output in string. We made the output in list so that we can use it and manipulate it very easily. This is about X built-in function. Let us see about ID built-in function. This is a syntax for ID built-in function. So what is the use of this function is, this function will return an unique constant integer which is assigned to that particular object in its lifetime. In Python, every new object has a unique constant integer assigned to it. With the help of ID built-in function, we can obtain that unique constant integer which is assigned to that particular object. Let us run the code and check the output. For X, this is an ID. For F, this is an ID. For D, this is an ID. This is about ID built-in function. Let us see about input built-in function. This is a syntax for input built-in function. This is a very useful function because with the help of this function only we can obtain the input from the prompt or from the console. There are two ways. One is this and another is using this arrow. Whatever input you are obtained, the input will be only in the form of string. Even if you are going to give the input in the form of integer, the input will be converted to string and it will be assigned to S and R. This is about input built-in function. Let us run this code and see the output. This is about input built-in function. Let us see about int built-in function. So what is the use of this function is, this function is used to convert the given value to an integer value. For example, int 5.5, this is a float, this is a string. This will convert the given value to an integer. So there are two parameters, one is the value and another is a base. By default the base is 10. That means if only one argument is there, by default that will consider the base as 10. If we are giving some base as 8, that means we are saying the given input is in the form of base 8. This is 17 is an octal number, and if the input is 2, base is 2, we are saying 1 is not 11. This is a binary number. Convert this binary number to an integer. Convert this octal number to an integer. This is about in built-in function. Let us run this code and check it. If we see here, means here the float is converted to integer, here the string is converted to integer. Here the 17 is an octal number. This 17 octal number is converted to an integer, that is 15. Here 1 is a binary number. This binary number is converted to an integer, so that is 3. The binary value of 3 is 1. That is what here. So this is about int built-in function. Let us see about ISINSTANCE built-in function. This is a syntax for ISINSTANCE built-in function. It contains two parameters, one is the instance and another is a class. So what is the use of this built-in function is, it will check whether this particular instance belongs to this class or not. For example, let us take this class cat, which has instance C1, C2. C2 is not an instance of class cat. Now we are checking whether C1 is instance of cat. Yes, that means C1 is an object of cat. Yes. C3 is an object of cat. No, this is a variable. Similarly, 5 is an integer. Yes. 5.5 object belongs to class float. Yes. This belongs to string. Yes. Let us run the code and check the output. For this is the answer, true. For this is false. 5 is an integer, yes, true. 5.5 is a float, yes, true. Vict is a string, yes, true. This is about ISINSTANCE built-in function. Let us see about ISSUBCLASS built-in function. This is a syntax for ISSUBCLASS built-in function. It contains two parameters, one is the class and another is the parent class. So what is the use of the ISSUBCLASS built-in function is, it will check whether this particular class belongs to this parent class or not. If yes, it will return true. If not, it will return false. In this example, if you see, animal is a class, cat is a subclass of animal, eagle is a class which is not a subclass of anything. Now we want to check whether cat is a subclass of animal. Cat is a subclass of animal, yes, so it will return true. Whether eagle is a subclass of animal, no, so it will return false. Let us run the code and check the output. For this is true. For this is false. This is about ISSUBCLASS built-in function. Let us see about ITER and next built-in function. This is a syntax for ITER and this is a syntax for next built-in function. First let us see about ITER built-in function, which takes two parameters, one is an object and another is a sentinels. So what is the use of this built-in function is, this will return an iterator object. For example, if the input is 4, 5, 6, 7, this will return an list iterator object. If you see print text and type of x, you can understand it. Let us run the code and check the output. So for this, we are saying this is a list iterator object and type of x is list iterator. This is about ITER built-in function. Now let us see about next built-in function. So it contains two parameters, one is an iterator and another is a default. What the next built-in function does is, it will find the next item from the iterator. With the help of next built-in function, we can retrieve the next item from the iterator. If no next item is there, it will return the default value. For example, in this, next of x will return 4, next of x will return 5, next of x will return 6, next of x will return 7, next of x, there is no element in this, so it will return the default value. So that's the reason it is coming 4, 5, 6, 7 and default is chella. This is about ITER and next built-in function. Let us see about object built-in function. This is a syntax for object built-in function. So what is the use of this function is, it is used to create an empty object. For example, if you are saying x is an object, then x, an empty object will be created. You can check it, an empty object is created using dir of x. Let us run the code and check the output. So here x is an object. If you see dir of x, these are all inbuilt properties. We can see there is no even a single attribute of user defined. So this is an empty object. This is about object built-in function. Let us see about oct built-in function. This is a syntax for oct built-in function. What is the use of this function is, this function is used to convert the given decimal number to an octal value. For example, the octal value of 7 is 7. The octal value of 12 is 14. So the answer will be 007 0014. 00 indicates 7 is an octal value, 14 is an octal value, not an decimal value. So this is about oct built-in function. We can create the octal value using format method also. This is the way to do it. Format 12, 0. Let us run this code and check the output. For this is the answer. For this is the answer. For this is the answer. This is about oct built-in function. Let us see how to create an oct built-in function by Haskell. Let the name of the function be oct1. The input is greater or equal to 8. We are finding the remainder and we are storing in B. Next step, we are finding the quotient and we are replacing x with the quotient. We are running the loop until the x becomes less than 8. If x is less than 8, we are storing the final value to B and we are returning the octal value. Now let us run this code and check the output. Here oct1 is the function which we have created. Oct is an inbuilt function. Let us check whether both the function gives the same answer or not. For 898, the octal value is 1602. Answer is 1602. For 11, it is 13. Here also 13. So this is about oct built-in function. Let us see about open built-in function. This is a syntax for open built-in function. The parameters are file, mode, buffering, encoding, errors, new line, closed FT and opener. But the important parameters to be noted are file and mode. So what is the use of this open built-in function is, with the help of this function, we can open the file in the mode which we are going to specify. Before entering into the coding part, let us understand what are the different modes available in open built-in function. R means we are opening the file for reading mode. W means we are opening the file for writing. X means we are creating a new file. If already a file is existing, it will create an error. A means we are opening the file for appending mode. B means we are opening the file in binary mode. If I want to read and write, then I can use R plus sign. This is about different kind of modes in open built-in function. Now let us enter into the coding part. In this program, we are opening a file name called as file testing. The mode of opening is read mode. After this, we are reading the file using read. This is a syntax to read the content of the file. After reading it, we are printing it. Once a file is open, we want to close it. So we are using file name dot close. Let us run the program and check the output. These are the content of the file. This is the file. This is the file. We have read this content and we have printed it. This is about read mode. Now let us see about read in binary mode and check the output. Change this to RB. Now let us run the code and check the output. If you see here means B is coming. This indicates this is a binary mode. We have read the file in binary mode. This is about opening the file in binary mode. Let us see about append mode. Now we change this into A. Instead of reading, what we are going to do is we are going to write it. Using A, we are appending. What we are going to append is this particular string we are going to append in the file which we have seen. Let us run the program and check the output. Now let us open the file. If you see here means the string is appended at the end of the file. This is about append mode. Now let us see about write mode. For this, what we are going to do is we are going to write mode string in the file. Let us run this program and check it. If you see the output, the string write mode has replaced all the previous content. So the basic difference between the appending and write mode is append will append at the end of the file. Write, what will do is it will remove all the previous data and will replace with this particular data. This is about write mode. Now let us see about EXCE mode. This is a EXCE mode. Now we are planning to create a file called as file testing 5. File testing 5 is not there. If already in this particular name a file is there, means it will show an error. Let us run this code and check the output. If we see here, means file testing has created. File testing 5 has created. This is about EXCE mode. Now let us see about plus mode. So what is the last output we have seen in file testing is the entire file has been replaced by write mode. If you are going to read this, it will print write mode. If you are going to write this plus mode, means again if you are going to open the file, it will show write mode plus mode. Let us run the code and check the output. If you see here, means this is what we have read and after that we have written. So this is the use of plus mode. So with the help of open built-in function, we can open the file in read mode, write mode, append mode, binary mode, plus mode, and also we can create a new file. This is about open built-in function. Let us see about power built-in function. This is the syntax for power built-in function. It contains 3 parameters. One is base, exponential, and modulus. If only 2 arguments are given, this will return base to the power of exponential. In this case, 3 to the power of 4, that is 81. If 3 arguments are given, what it will do is it will find 3 to the power of 2, that is 9 modulus 2. So 9 modulus 2 is 1. So this will return 1. Let us run this code and check the output. For this is the answer. For this is the answer. This is about power built-in function. Let us try to create the power built-in function by ourselves. This is one of the way to do it. Let the name of the function be power1. The parameters are b, e, and m. By default, we are setting m to the maximum value, and what we are returning is b to the power of v modulus m. So for this 7 to the power of 5, it will return 7 to the power of 5. For this will return 7 to the power of 5 mod 2. Let us run the program and check the output. 7 to the power of 5 is 16807. So 16807 mod 2 is 1. So this is our function. This is inbuilt function. So this is about power built-in function. Let us see about print built-in function. So this is a syntax for print built-in function. The parameters are object, separator, end, file, and flash. For example, if you are going to print 24, the output will be 24. If you are going to print 1, 2, 3, sep equal to star star means what the separator does is this will separate these 2 elements by star star. The answer will be 1 star star 2. Again 2 and 3 is separated by star star. So the answer will be 2 star star 3. So in this example, if you see means 1, 2, 3 end means, so it will end by dot dot dot. So the answer will be 1 space 2 space 3 dot dot. So in this example, if you see means 1, 2, 3 sep equal to star star end equal to dot dot. That means The two elements are separated by star star and the final things is ended by dot dot. Let us run this code and check it. Here the answer is 24 for this 1 star star 2 star star 3, for this 1 space 2 space 3 dot dot. So this output is for this and this output is for this particular thing. Why it is not printing in next line is, so if you are going to use n, the next print will continue from the same line. This is about print built-in function. Let us see about property built-in function. Property is a decorator in Python. In this example, employee is a class which takes first name as a last name as an argument to one constructor. Based on the first name and the last name, this is producing the full name. Full name equal to first name plus last name with space. Here E is an object based on this employee constructor Chelladurai. So E dot full name will give Chella space Durai. If I want to change the first name to Raju, whether E dot full name will be Chelladurai or Raju Durai, let us run this program and check the output. E dot full name is coming Chelladurai, the Raju is not reflecting here. So what the program will do is, they will convert this attributes. They will convert this attributes to function. So they will remove this self dot full name and will create a method called full name, and it will return self dot first name dot self dot last name with a space. Now with the same code, if you run the code, now the Raju Durai, this change is reflected here. Assume that thousands of people have done the code based on this. In MNC company, thousands of people have done the code based on E dot full name. If they want to change into E dot full name bracket, they want to change thousands of codes, which is a tedious process. To overcome this, the property function plays an important role. If you are going to write at property full name self, the same thing. Now what we are going to do is, we are going to run this program. If you see the output, this change is reflected here. But whether we have changed anything here, whether we have added any brackets here, no. So with the help of this property built-in function, this method is called as an attribute. So because of this, lot of unwanted change in the code is avoided. This is the use of property built-in function. Let us see about range built-in function. This is a syntax for range built-in function. It contains three parameters. One is start, stop and step. So what is the use of this function is, this function is used to produce sequence of numbers. Let us see this with an example. Here we are giving range of 3. Here there is only one argument, but there are three parameters. One is start, stop and step. If only one argument is given, then what will be the value of start? What will be the value of step? What will be the value of stop? If only one argument is given, the start will assign to 0, the step will assign to 1 automatically. So it will start from 0 and it will end at 2. 3 means it will end at 2 before the previous value with a step size of 1. So the answer will start from 0, 1 and 2. If it contains 2 arguments, for example in this case it contains 2 arguments, then what is the value of step, what is the value of start and what is the value of stop? Here the value of start is 2, the value of stop is 10, the value of step is 1. By automatically it will assign to 1. So it will start from 2 and it will end at 9. That is previous value. 10 is there means what is the previous value for 10? 9. So it will end at 9. So the answer will become 2, 3, 4, 5, 6, 7, 8, 9 with the step size of each one. If it contains 3 arguments, then this will assign start as 2, stop as 10, step as 3. Here the step size is 3. You must note here the step size is 3. So it will start from 2. The next value will become 2 plus 3, that is 5. The next value become 5 plus 3, that is 8. another next value will become 8 plus 11, that is 11, which is beyond stop. So the answer will become 2, 5 and 8. This is about range built-in function. So all these answers are in ascending order. If you think that I want the answer in descending order, then you want to use a step size in negative manner. Here the start is 10, the stop is -1, the step is -2. So it will start from 10 and it will decrement by -2, that is 8, 6, 4, 2 and 0. It will end at 0. So this is about range built-in function. Let us run this code and check the output. If you see here, means for this is output, for this is output, for this is output, for this is the output. This is about range built-in function. Let us see how to create the range built-in function by ASCII. Let the name of the function be range1. Here the parameter is star a, that means any number of argument can be given as an input. Star a means any number of arguments can be given as an input. In the built-in function we have seen there is one argument, there is two argument, there is three arguments. If one argument is coming, the start is assigned to 0, the step is assigned to 1. If two argument is coming, the step is assigned to 1. If three argument is coming, the values are assigned to this start, stop and step. So the first thing to be done here is the length of a is 1, that means only one argument is given. The start is assigned to 0, the step is assigned to 1. a of 0 is assigned to end. If two argument is giving, a of 0 is to start, a of 1 to end, step is assigned to 1. If three arguments is given, a of 0 to start, a of 1 to end, a of 2 is step. So first we have assigned the start value, the end value and the step value. Next we want to know whether we want to increment in ascending order or descending order. If you want to produce the output in ascending manner, we want to execute this code. If you want to produce the output in descending sequence, we want to execute this code. If step is positive, then this code must be executed. If it is negative, then this code must be executed. Let us take an example. If start is 0 and end is 3, whether 0 is greater or equal to 3, no. So it will come to here. So x will be appended with start. What is the value of start? The start is 0. So x 0 will be appended to x. Now the new value of the start is 0 plus 1 is 1. The start is 1. Whether 1 is greater or equal to 3, no. So 1 will be appended to x. Again the start will be replaced by 1 plus 1, that is 2. Whether 2 is greater or equal to 3, no. So 2 will be appended to x. Now again the start will be assigned to 2 plus 1, that is 3. Whether 3 is greater or equal to 3, yes. So this will return the x value. So what is the value of x? 0, 1 and 2. So this will return 0, 1 and 2. Now let us check the function which we have created. This is range 1. This is an user defined function. We have created this function. This is for argument 3, 2 and 10, 2, 10, 3, 10 minus 1 minus 2. Let us run this code and check the output. You can see for 3 it is coming 0, 1, 2. For 2 and 10 it is coming 2, 3, 4, 5, 6, 7, 8. For 2, 10, 3 it is coming 2, 5, 8. 10 minus 1 minus 2 it is coming 10, 8, 6, 4, 2, 0. This is about range user defined function. If you check this output and this output, both are same. So this is one of the way to create range built-in function. Let us see about REPR built-in function. This is a syntax for REPR built-in function. So what is the use of this function? This function will return a string in the printable representation of an object. So what is the basic difference between an ASCII and a REPR is, the ASCII will convert the non-ASCII character to an ASCII and it will return a string. The REPR won't convert the non-ASCII character. It will just return the string within the quotes. For example, here x is my name is so and so. If you are going to print x, it will return my name is so and so. If you are going to use REPR of x, it will write my name is so and so within the quotes. So very important point, REPR of x will return the string within the quotes. So this is about REPR built-in function. Let us run the program and check the output. This is x, this is REPR of x. This is about REPR built-in function. Let us see about reversed built-in function. This is a syntax for reversed built-in function. So what is the use of this built-in function is, this function is used to reverse the given iterate. For example, here d is 4263. So this reversed built-in function will reverse the given list and will return the value. Let us run the code and check the output. So the answer is 3624. This is about reversed built-in function. Let us create the reversed built-in function by ourselves. The name of the function is reversed one, and this is one of the way to do it. What we are doing here is, we are storing the value from L-1 to 0. That means we are starting from here and we are storing the value in reverse direction and we are returning R. Let us run the code and check the output. If you see the output, it is 3624. 3624. This is about reversed built-in function. Let us see about round built-in function. This is a syntax for round built-in function. It contains two parameters. One is the number and another is n digits. If only one argument is there, what we are saying here is, please round to nearest integer. For example, 3.2 is less than 3.5, so it will round to 3. Here 3.6 is greater than 3.5, so it will round to 4, which is the nearest integer. If two arguments are given, here the n digit is 4, please round 4 values of the decimal point. Let us run the code and check the output. For this is 3, which is an integer. For this is 4, rounded to nearest integer. For this is a float, which is output of this given input. This is about round built-in function. Let us see about frozen set and set built-in function. This is a syntax for set and this is a syntax for frozen set. This function will convert the given iterable to set. For example, if the input is list, this will convert to set. Similarly, if the input is list, this will convert to frozen set. So what is the difference between the frozen set and the set is a mutable one. We can change the values, but frozen set is an immutable one. After initialization, we cannot change it. For example, here the value of the set is 1, 2, 3, 4. We are updating 5 and 6, 7. So the new value of x will be 1, 2, 3, 4, 5, 6, 7. So we can update it. Here the frozen set is 1, 2, 3, 4. We are trying to update by 5, 6, 7. It will create an error. So before updating the frozen set, let us run the code. So we can see clearly the set is, initial value of the set is 1, 2, 3, 4. The updated one is 1, 2, 3, 4, 5, 6, 7. The initial value of the frozen set is 1, 2, 3, 4. Now let us try to update the frozen set. Let us uncomment it. Let us run the code. So if we are going to try to update the frozen set, there is an error. The frozen set object has no attributes update. That means we cannot update the frozen set. So this is about set and frozen set built-in function. Let us see about slice built-in function. This is a syntax for slice built-in function. It contains three parameters. One is start, end and step. See, for this input, if we are saying slice of 2 means only one argument is given, the start will be assigned to 0, the step will be assigned to 1 automatically. If 2 argument is given, the step will be assigned to 1. If 3 argument is given, the start will be assigned to 0, the 8 will be assigned to n, 2 will be assigned to step. In this case, it will start at 0 and will end at 1. That is, A and B will be the answer. In this case, it will start at 2 and will end at 5th element. That is, C, D, E, F. In this case, it will start at 0 and will end at 7th element with the step size of 2. So answer will be A, C, E, G. Let's run the code and check the output. So for this is the output. For this, starting at 2 and ending at 5, this is the output. For this, A, C, E, G. This is the output. This is about slice built-in function. Let us create slice built-in function by ourselves. This is one of the way to do it. Here we are starting from 0 and ending at 1. Here we are starting at 2 and ending at 5. Here we are starting at 0 and ending at 7 with a step size of 2. Let us run this code and check the output. AB, AB. 2 means it will end at 1. 6 means it will end at 5. 8 means it will end at 7. So the answer is AB. For this, DEF. For this, A, C, E, G. This is similar to this. This is about slice built-in function. Let us see about sorted built-in function. This is a syntax for sorted built-in function. It contains 3 parameters. One is iterable, key, and reverse. By default, the key is none, the reverse is false. If the reverse is false, it will sort in ascending order. The reverse is true, it will sort in the descending order. For example, take this list, let us sort it and find the answer. For this one, this is printed, this is sorted in ascending order. For this one, this is sorted in descending order. This is about sorted built-in function. Let us see about split built-in function. This is a syntax for split built-in function. It contains 2 parameters. One is a separator and another is a maximum split. So what is the use of the split built-in function is, with the help of this function, we can split the given string into a list based on the separator. For example, here the string is I, how are you? All these things are separated by space. X1 is hi, how are you? Separated by comma. Now we are trying to split X based on space. We are trying to split X based on the space. So the list will contain I, how are you? Similarly, we are trying to split X1 based on comma. So the list will contain I, how are you? Now what we are doing here is, we are trying to split X1 based on comma, and the number of maximum split is 2. That means you split I and how are you, rest you don't split and give the output. Let us run the code and check the output. For this one, this is the answer. We are splitting based on space. Based on space, we are splitting it. For X1 dot split, we are splitting based on comma. So based on comma, this is the output. Based on comma, we are splitting it and we are making into a list. For Y1, we are splitting based on comma, but the maximum split is 2. So you are splitting I and how, and we are not splitting are you. This is one element. So this is about split built-in function. Let us see about static method. In Python, static method is a decorator. In Java, we know that if a variable is static, that means this variable is common to all the objects. For example, let us consider E1, E2, E3 as an object of this class employee. If we are going to change E1.x equal to 7, this thing will be reflected in E2.x as well as in E3.x. E2.x and also E3.x will become 7. So, if a variable is static, this variable is common to all the objects. Similarly, if a method is static, this method is common to all the objects. This does not depend on the data of that particular object. That's the reason we don't have self. Here if we see here means the parameters are initial salary and number of years, and this is returning initial salary plus 2000 into number of years. So a static method is a method which is common to all the objects. It is not bounded to one particular object. If we see here means we are writing employee.current salary 10,000, 5 means the answer will be 10,000 plus 2000 into 5, that is year 10,000, year 10,000, 20,000. Let us run this code and check the output. In Python, if we say a method is static, that means this method is common to all the objects. This is about static method. Let us see about string built-in function. This is a syntax for string built-in function. These are the parameters. One is object, encoding, and error. If an object is an integer, this will convert into string. If an object is a bytes, then it will be encoded using any encoding method, either UTF-8 or ASCII. While encoding, if any error is occurring, we can mention what kind of handling the error must do. So if we take here once X, it's a bytes. Here the byte is encoded using ASCII value. Since this is an ASCII value, so this and this won't be there while converted to string. And if any error is occurring, we are saying please ignore it. Let us run the code and check the output. For this is a string. For this is CDER. Here this and this, the non-ASCII characters are removed and this bytes is converted into string. This is about string built-in function. Let us see about some built-in function. This is a syntax for some built-in function. It has two parameters. One is iterable and another is value added. By default, the value added is 0. If only one argument is there, it will add all the elements in the given iterable and return the sum. If two arguments are there, it will sum all the elements in the given iterable and add plus 10 and returns the sum. This is about some built-in function. Let us run the program and check the output. For this, if you add all this element, it is 21. For this, 21 plus 10 is added, so it is 31. This is about some built-in function. Let us create the sum built-in function by ourselves. This is one of the way to do it. We are taking two parameters. By default, we are making VAD equal to 0 and we are summing the element from the beginning to the end. At last, we are returning sum plus VAD. If VAD is 0, it will return SM alone. If VAD is there, it will return SM plus VAD. For the same input, let us run the output and check the output. 21, 31. 21, 31. This is about some built-in function. Let us see about super built-in function. This is a syntax for super. So what is the use of this function is, with the help of this function, we can access the parent methods and attributes. Let us see an example. Here, animal is a class which contains eat and sleep method. Inside eat method, this is going to print inside animal eat method. Inside sleep method, this is going to print inside animal sleep method. Let us create another class called cat, which is a subclass of animal. That means animal is a superclass or parent class. Cat is a child class or subclass. Inside this class cat, we are having a method called as eat. Inside this, we are going to print inside cat eat method. Now let us create an object called C for the class cat. With the help of that object, we are going to access the methods. So c.sleep and c.eat. If you see that c.sleep, whether cat has sleep method, no. Then it will go to the parent method. It will check whether sleep is there, yes. So it will print inside animal sleep method. Similarly, if you see that c.eat, if you see means here also eat method is there, here also eat method is there. The C object can access this eat method or this eat method. So which eat method it must access? So this c.eat will access this eat method rather than this. This is called method overridden. This method is overridden by this method. So the answer will be inside cat eat method. But if I want to access the eat method from the parent class, then what should I do? Then I'll be using super.eat. Super means this class animal dot eat. Then we'll be printing inside animal eat method. So what is the use of super.eat? How this is accessing the class animal and is printing EAT method is the super will create an proxy object. For example, animal is a class, we have seen it. It will create a proxy object. Based on this object, will be accessing the EAT method. Here this is a proxy object. A is a proxy object for animal. Based on that, will be accessing EAT method. Now if you are going to run this code, uncomment this and run the code, we can see inside animal EAT method is accessed using super.eat. So what is the use of super is, the super will create a proxy object. From this object we can access the methods using the proxy object. So this is the use of super built-in function. Let us see about tuple built-in function. This is a syntax for tuple built-in function. It takes an iterator as an argument and it converts that into tuple. For example, this is a list, this is a set. Here the tuple of x means it will convert the list into tuple. Tuple of y means this will convert the set into tuple. Let us run the code and check the output. This is tuple and also this is tuple. This is about tuple built-in function. Let us see about type built-in function. This is a syntax for type built-in function. So what is the use of this type built-in function is, this function will return the type of the given input. For example, here the input is an integer, so the type of I is integer. Here this is a string, the type of hello is string. This is float, so type of 5.5 is float. This is a list, so type of x is list. Similarly, it go for tuple, set and dictionary. So the use of type built-in function is, it will return the type of the given input. Let us run the code and check the output. For 5 it is int, for hello it is string, for 5.5 it is float, for this is a list, for this is a tuple, for this is a set, for this is a dictionary. This is about type built-in function. Let us see about zip built-in function. This is a syntax for zip built-in function. It takes any number of arguments as an iterator and returns a single iterator. For example, if you see in this example, this is a list iterator, this is a tuple. What the zip built-in function is doing here is, this is combining these two iterators into a single iterator. Let us run this code and check the output. So if you see here means, say this is 1 and 4, 1 is from list, 4 is from tuple, 2 is from list, 5 is from tuple, 3 is from list, 6 is from tuple. So it is combining these two iterators and is returning a single iterator. Now what we are making is tuple of tuple. That means this tuple contain tuple elements. For y, it contain list contain tuple elements. This is about zip built-in function.